Now we want to look at some equations, some simple equations. So I'll start with the very basic equations, and then gradually we increase the complexity of the problems as we go along. So here's an equation, x plus 2 value that we need to find of dealing with these type of problems. So solving this equation means to isolate x by itself on either side of the equation, either on the left hand side or the right hand side. But since we already have x on the left hand side of the equation already, we can let it just stay there. And then that positive 2, we need to get rid of that positive 2. And therefore, to get rid of the positive 2 there, we subtract 2. But remember, very, very basic principle, and the one principle that governs all equations is that whatever is done to one side, the same has to be done to the other side of the equation. And since I subtracted 2 from the left hand side, I also need to subtract 2 from the right hand side. So here, 2 take away 2, leave us with 0, nothing, right? And 7 take away 2, leave us with 5. So our solution here is for x equal to 5. Remember the original problem? X plus 2 equal to 7. That was the original problem. And the beauty about solving equations, we can always test your solutions. By testing, I mean you could just plug or substitute the value of x in the original equation. We found x to be 5, so we can test it. 5 plus 2 is equal to 7. So we know our solution is accurate. Now let's look at x plus 2 equals 7 again. And I am fully aware that the way a lot of us learn to deal with this type of problem is to bring over positive 2. And we learned that we were taught that anything goes across the equal sign, it changes. So if it's positive, it becomes negative, and if it's negative, it becomes positive. So you will say positive 2 come over the right hand side, becomes minus 2. I will not bash that method because it works. It always works. So I definitely will not bash it. But in principle, that is not what's happening here. What's happening is that we are subtracting 2 from both sides. So we have x plus 2 is equal to 7. So we subtract 2 from the left hand side. We're left with x. Or remove 2 from the x left hand side. You're left with just x. And if you remove 2 from the right hand side, meaning you remove 2 from 7, or you subtract 2 from 7, then you're left with 5. So in principle, that's exactly what's happening here. Let's look at another problem. X minus 2 is equal to 10. And as always, a very basic one, you could always look and say, okay, what do you subtract 2 from to get 10? And you look at it and say, okay, that seems to be 12. X is 12. Remember, x is some unknown number that we're trying to find. So I want to look at the systematic way we were doing earlier. So, if you recall the previous problem, we had positive 2. And how did we get rid of that positive 2? That's correct. We use additive inverse of positive 2, which is negative 2. Alright, so now we have negative 2. So we want to get rid of negative 2, so we add 2. So when you have positive 2, we deduct 2 or subtract 2. Now you have negative 2, to move that you add 2. Just do the opposite. Alright, so we have x minus 2. So remember the aim of the game here. We want to remove this 2, negative 2. Why? We want to isolate x. So negative 2 and then we add 2. But because we add 2 to the left hand side, remember the very basic principle, we also need to add 2 to the right hand side. So negative 2 plus 2 gives us 0. And 10 plus 2 gives us 12. So our solution there, x equal to 12. And the beauty, as I said, the beauty about equations, you can always test your solutions by substituting 12 for x in the original equation. And what you'll have is 12 minus 2 equal to 10. And this proves that the solution is actually 12. Now again, let me not ignore the way some of you were taught on how to solve problems like this. And again, I know a lot of us, including myself, while I was in high school, I always thought that you bring over the minus 2. And whatever goes over the equal sign, cross the equal sign, if it's negative, it becomes positive. And if it was positive, it becomes negative. And I said earlier, I will not bash this method because it works 100% every time. So x is equal to 12. Alright? Let's look at another one. So here we have 2x plus 1 is equal to 15. So 2x, what is 2x? 2x means 2 times x. So that's normally when you have a number and an unknown, a letter, together like that. So it means it really means 2 times. But we don't, traditionally, we don't really put the multiplication sign there. So 2x really means 2 times x plus 1. So 2 times a number plus 1 is equal to 15. What is that number? What number does x represent? That's what we want to find. And of course, you can look at it and guess it. 2 times a value plus 1 give you 15. And I'm sure a lot of you have guessed it correctly so far. No, you double a number, you add one, you get 15. The result is 15. What is that number? Right? It's 7. But let's see how I get that 7 here now. So we need to minus 1 from both sides. Alright, so we first want to get the 2x by itself, or the term with the x by itself. The term with the x there is 2x, right? So I want to isolate that by itself here. Good? So 2x plus 1. So we need to subtract 1 from the left hand side. We need to move that 1 from the left hand side. Alright, so move this 1 from the left hand side. And because we move this 1 from the left hand side, we also need to subtract 1 from the right hand side. So we subtract 1 from the left hand side, we'll be left with just 2x. But remember, we have to subtract 1 from the right hand side. And I know a lot of you is looking and say, okay, what actually happens is, right? Positive 1 comes across the equal sign, it becomes minus 1. But technically speaking, in principle, then positive 1 did not go across the equal sign. Technically speaking, what that means is that we subtract 1 from both sides. So we subtract 1 from the left hand side. There's 1 no more. But remember, we have to subtract 1 from the right hand side also. So we end up with 2x is equal to 14. No, 2 times a number equal to 14. X is a number, don't forget. So 2 times x, 2 times a number gives us 14. What is this number? Yes. Alright. But to get rid of this 2 here, we divide by 2. And remember, basic principle of the equation, whatever is done to one side the same has to be done to the other side. Good? So we divide the other side by 2 also. Alright, so 2 into 2 goes 1 time. Remember, anything divided by itself gives you 1, right? So what you really have is 1x. But 1x is same as x, so 1x x. Alright? And 14 divided by 2, what's that? 7. And again, you can always test your solution by replacing the x with 7. So we'll have 2 times 7, which is 14. 14 plus 1 give you 15. So we know 7 is the solution. Here's another problem. Another equation to solve. And by solving, we are being asked to find the value of p. So whether it's x or p or m or l or q or whatever letter in the alphabet, the approach does not change. Alright, so here we have the unknown p on both sides. Any ideas what to be done? Yes, you're correct. We group all the like terms. All the like terms. Good? No. So group all the like terms. So we have 4p here. And this is one of the times when we're using grouping, that idea where I said that when a term goes across equal sign, it changes positive turn negative, negative turn positive. I guess it's useful in these cases, but so we need to group the p's, but technically what happened? We're subtracting p's from both sides. So we're subtracting p from the right hand side, there's no more p, just 13. And we have to subtract p from the left hand side also. In principle, that is exactly what's happening. But I know a lot of you, right, how you're taught, p goes across the left hand side. Because the p is positive here, when p comes across, it becomes negative. I won't bash that. Alright, here we have 13. 13 remain 13. Alright, so we have negative 5. And again, what really is happening here, you want to add 5 to both sides. Because to get rid of the negative 5, you add 5. And it becomes 0. The overall value becomes 0 when you add positive 5 to negative 5. But because you add positive 5 to the left hand side, you also need to add positive 5 to the right hand side. So we group the like term. So we group all the terms with p on one side, and all the terms, well, all the constants we call them, just the numbers we put on the other side, the right hand side in this case. So you'll notice, if you want to look at it like that, minus 5, no positive 5 over here, p, negative p. But again, as I said earlier, add 5 to both sides, and you subtract p from both sides. So 4p, and by the way, p really means 1p. Alright, so p is really 1p, just as how x is 1x. Alright, just that traditionally we don't normally put the 1 in front of the term here, but it's 1p. So it's negative 1p here. Alright, so 4p minus 1p, that's 3p. And 13 plus 5, that's 18. So here we have 3p. 3p really means 3 times p. So 3 times a number give you 18. P is a number, don't forget. So what is that number? Right? We can say, okay, you want to isolate the p, so you want to get rid of this 3. So you divide this side by 3 to cancel 3. Or, well, can say it's not a proper term there, 3 into 3. So left 1. Remember, anything divided by itself will give you 1. So 1p, still p. But remember, since you divide the left hand side by 3, you also need to do the same to the right hand side. So here we have 1p, which is just p. And 18 divided by 3, which is 6. So the value of p is